Greetings. Welcome to one more session of Physio TV session. Today we are going to discuss about testing the apparatus, which is the syllabus of first year BPTH under the MUHS. Let me share the PowerPoint. So shortwave dithermy is one of the very useful apparatus in treating the patients. It is almost present in every physiotherapy clinic and is one of the deep heating modality we often use for treating our patients. So today's objectives are, we are going to understand how to define shortwave dithermy. We are going to discuss about the production of heat in shortwave dithermy, and then different methods of testing shortwave dithermy apparatus, and what are the steps to follow to test the apparatus, and finally the practical demonstration of the same. So as we know, the word is derived from these two words, shortwave. We understand that short waves are the radio waves, and the word diathermy, dia is through and thermo is related to the temperature or the heat. So here basically we can define the shortwave dithermy as a means of producing therapeutic heat within the tissue by the use of radio waves. So these radio waves are present in the high frequency in the electromagnetic spectrum. If you see the electromagnetic spectrum, in that the high frequency part is related to the radio waves. And in this, short waves are one of the components of this radio waves. And the medical authorities have dedicated a frequency of 27.12 megahertz with a wavelength of 11 meters dedicated for shortwave dithermy. So we have 2 or 3 frequencies which are dedicated for our shortwave dithermy machines. The most commonly used one is 27.12 megahertz. So if we see how the heat is produced in shortwave dithermy, generally if you see the other superficial thermal agents, generally we transfer the heat by conduction. That means generally first the electrodes get heated and that heat will be transmitted into the tissues. But in contrast, in shortwave dithermy, the heat is not produced in the electrodes, but the heat is produced within the tissue. So the heat is produced in the tissue under the influence of the electrostatic field. So by 3 methods. What are these 3 methods? The first one is we have abundant ions, which we call them as the charged molecules. So these charged molecules vibrate under the influence of static field. Then second method is rotation of dipolar molecules. So we have a majority of the molecules which are polarized. That means they have a negative pole and the positive poles. Under the influence of electrostatic field, they cannot dissociate, but they just try to rotate, and this will also produce some amount of heat. Then thirdly, we have non-polar and the fat molecules, which generally get distorted when we apply SWD or the electrostatic field. Now, out of these 3, the most of the heat is produced by the vibration of charged molecules. And apart from the thermal effects, we also have non-thermal effects SWD, for which we use pulsed shortwave dithermy. Now, let us just highlight the production, main part of the production, that is the heart of the SWD machine. So we have the oscillator coil. This is the basis for the production of high frequency current. So here basically we have a capacitor and an induction coil. So this combination gives us a high frequency current. So every set of combination of capacitor and induction coil will give you a different frequency. So in shortwave dithermy production, the set of capacitor and induction coil is selected such that the result is the production of high frequency current at the rate of 27.12 megahertz. So that is the basis for the production of shortwave dithermy. Then coming to the actual part of testing. So here I've seen that every teacher has their own method of testing apparatus. So basically, when I have gone through several testing of electronic apparatus, so I found this, and I found that this is the most appropriate method to test the machine. So here it has the following components. First, whenever you take the apparatus, the visual inspection is the first one. So you should check for any physical damage on the machine and see that there are no loose objects which are floating or which are moving in the diathermy machine. So visual inspection and then observing it in all the directions for any damages. Second, that is in the visual inspection, we also check all the components of the machine. Then the earth continuity. So this earthing, the connection of the earthing is very important to prevent the shock. In physiotherapy department, it is a must to have a proper earth connection to all the apparatus. So generally for this purpose, we use a 3-pin plug. In this, the first one which has larger pin is the one which is responsible for earth connection. So we should be sure that this earth is working, this earth connection is working. Second, insulation resistance test. So here, whatever the cables we are using, we should see that they don't have a lot of resistance. So the resistance should be within the permissible range. For this, we have a resistance test. If the resistance increases, the apparatus may malfunction. Next one is the leakage test. So whenever we are using a radio frequency apparatus, so there is always a risk of the leakage of the current. So we should check them thoroughly for this leakage test. And finally, the machine specific tests for whenever you are testing the respective apparatus. So here we generally have an input test, output test, the quality of the leads, then specific testing for each machine. In short-wave diathermy, we have 2 methods of testing, which will explain you in the next slides. So the first one is the visual inspection. So the apparatus on the whole should be checked for any physical damages. Very similarly, the electrodes which are used, the mains cable, the power cable. Then we have the leads which connect to the electrode. So we should see that they don't have any physical damages and they are of good condition. So the second part of the testing is earth continuity. Now this is something which is new for us. So here basically there are 2 methods by which we can test the earthing. So we all know that in a power plug, we have earth connection. These 2 are the earth connections, 1 and 2. And then we have on the right side, we have the phase or the live wire. And on the left side, we have the neutral. Okay, so this is the phase and this is the neutral. So what happens is when we test the apparatus by using a tester, what we do is we generally connect, when we insert the tester into the live wire or the phase point of the power plug, generally it glows. Okay, and it doesn't glow in neutral and earth. So this doesn't mean that it is working, whereas there may be a discontinuation of earth connection or neutral connection. So if you want to test this, what you can do is there are 2 methods. One is using multimeter, using an electrical bulb. Okay, so how do we test? We'll go to the procedure. First thing, when you are using a multimeter, you have to move the knob of the multimeter to the voltage mode. Once you take it to the voltage mode, here one of the lead of the multimeter will be connected to the live wire and another first to the neutral wire. Okay, when you are connecting to the neutral, generally the meter shows you the reading. Generally it is in the voltage mode, so it shows you 230 to 250 volt. Okay, this confirms that the neutral and live both are working. Okay, and coming to the testing of earth connection, which is another important aspect. So at the same time, what you do is you connect one live wire to the one of the lead to the live wire, that is the phase, and another to the earth. Again, here it should show the same reading which it was showing in the neutral. That is, the range should be 230 to 250. So if the voltage reading is same in neutral and when connected to neutral and when connected to earth, it means that both of them are working. Suppose if the earthing is improper. When the earthing is improper, what happens is the potential, that is the voltage in the meter, will drop down. That means instead of 230, it may show you 150, 170, whatever. So that tells you that earth connection is improper. So earth connection is very important for preventing shock. On the contrast, we have second method of testing the earth continuity by using a bulb. So here we use two cables of the bulb which are connected to the bulb, one to the live, another to the neutral. Generally what happens is we know that the bulb will glow with its full potential when both are working, when live is working and neutral is working. Very similarly, when you connect it to the earth, it should glow with same intensity. If it glows with same intensity, that means earthing connection is proper. Okay, so this is a simple test to check the continuity of the earth. Next is insulation resistance test. Now here, the insulation testing is just to see that there is no risk of shock or accidental discharges. So what we do is, the main purpose of checking insulation resistance test is that, so the insulation resistance is the resistance which is measured in ohms, which is related to the wires, cables, and other electrical equipment. So what are we doing? What we are doing is we are connecting one of the lead of the apparatus, that is insulation tester. It can be multimeter, resistance test, whatever you use. So one is connected and another is connected to the main copper lead of the cable. So if there is any reading, that means there is some leakage or discharge in the cable. Okay, very similarly we can do it for the apparatus by connecting the body of the apparatus and the mains, that is the earthing, neutral, and the phase. So if there is any reading that is noted, that shows that there is some leakage. So there is some, so this is called as resistance testing. So why is it important? It helps us to guard against the electric shocks and also avoid equipment damage from accidental discharges. Next, a simple leakage testing. In this leakage testing, generally what happens is, if there is any leakage and if there is improper earth connection, only then there will be accumulation of charges on the body of the apparatus. And we know that the charges generally accumulate on the corners of the apparatus or corners of any surface. So what we do is we use a tester and we check the corners of the machine and the places where the metal clips are present, screws are present, where the paint or insulation is not there. So in those areas, we need to check for the leakages. On the paint, checking the leakage is of no sense. We have to check in those areas where the paint is scraped off or on the metal clips. Ideally, if you find any leakage, the tester will glow and that will tell you that there is some leakage in the apparatus and it has to be sent for the service. Next part of the testing is the tuning. So whenever you switch on the machine, and what happens is, once you switch on the mains, machine and everything, the output starts. And once the output starts, the ammeter shows you the reading. Okay, and if you have to tune the machine, then what you have to do is you have to move the tuner, which can be moved 360 degrees. So behind the tuner, we have a variable capacitor. This variable capacitor has a set of plates. One set of fixed plate, another set is the movable plate. So basically what we are trying to do is we are trying to match the capacitance of the patient tissue, which is placed within the electrodes, and the capacitance of the machine. So what we can do is, when both the electrodes are facing each other, we have maximum capacitance of the variable capacitor. Now one set is fixed, another can be moved. So when you move this, the capacitance decreases. So the other can be moved 360 degrees. So when it is perpendicular to the other set of electrodes, it has minimum capacitance. So basically, what we are trying to do is we are trying to match the capacitance of machine with the patient tissue. Okay, so we say the machine is tuned when the ammeter shows maximum reading. So what you do is, once the output is on, you try to move the tuning. So you try to move the tuning 360 degrees and you stop at the place where the ammeter shows maximum reading. Okay, so here on the ammeter, we see that there is a maximum reading, and that time you say that the machine is tuned. Okay, so if the machine is, if you are not able to tune the machine, that means if the output is not increasing at any point, that means there is something wrong with the machine. Okay, so for every apparatus, when you move it 360 degrees, there is one point at which the machine shows maximum output. Finally, we'll just review the steps in testing. First, we will place the apparatus on an insulating surface. Okay, then we'll connect the mains cable to the plug, and then we'll place both the electrodes on an insulating surface, and over the electrodes we generally place a towel for the insulation. And we see that both the electrodes are not very close, so we see that there is some distance between the two electrodes. And then we are over the towel, we place our hand so that there is placement of the hand on both the electrodes. Okay, then there are two methods of testing. The first one is by placing your hand. Second one is by placing a fluorescent lamp, a fluorescent or neon lamp. So now the steps to be followed are, once you are ready with the placement of the hand, the second one is switch on the plug, then switch on the machine, on off switch, which is generally a rocker switch with indicator. Once you switch on this, then next step is to switch the power on. So you have 5 levels on this power, and this is a 300-watt machine. That means the maximum output is 300 watts. So approximately for every intensity level of 1, there may be around 60-watt output, approximately a 60-watt output. That means at 1 it will be 60, at 2 it will be 120, at 3 it will be 180, and so on. Next, so once you increase the power to 1, there is an output you can see, and you can see some warmth on the hand in the first method. Okay, then you move the tuning knob 360 degrees to find a point where it shows you the maximum reading. So the point where it shows the maximum reading, you will say that is the point where the machine is tuned and it has maximum output. And simultaneously, you will feel more warmth in the hand when you are using the method 1. Very similarly, there is another method to test, that is by using a fluorescent or a neon lamp. So in place of hand, we place the neon lamp in the center of the electrodes. And very similarly, we increase the power to 1, and then ammeter will show you some reading. And when you tune, there is a point at which the lamp will glow with maximum brightness. So that is the point where we say that the machine is tuned. Okay, so these are the steps to be followed in testing the apparatus. So thank you, and now we'll continue with practical demonstration. We'll continue with the practical demonstration of testing the apparatus short-wave dithermy. First, I would introduce you to the parts of the short-wave dithermy. So here we have this short-wave dithermy machine, which is a mini one in nature. It is of 250 watts. So here first thing is we have a switch, which is a rocker type of on-off switch with LED indicator. Then we have this power knob. So this is the power knob where you can increase or decrease the level of the powers, which is a rotatory switch. And then you have a timer, a spring-based timer. Then you have a tuning knob, which is actually behind the tuning knob you have a variable capacitor, an indicator for the high frequency current, and then we have an ammeter in the middle. This ammeter is connected to the electrodes, which shows you the output of the machine. So tuning, ammeter, and the electrodes will be the machine circuit part. Okay, so now we will continue with the testing of the apparatus. So here basically first thing is physical examination. In the physical examinations, I am checking for any damages in this apparatus. I am checking whether everything is intact. That is the first part. Second, checking the electrodes. So we have in the capacitor field method, we have the electrodes. So you can see 2 electrodes which are in good shape. There are no damages in the leads. The leads are also intact, both the leads. Then we have the power cable. This power cable needs to be checked very carefully, because generally the site of damage is the necks of the connection, that is neck of the plug and neck of the socket. Generally these are the ones which generally get damaged. Okay, so it is a 3-pin plug. The first one is the neutral, this is the earth connection, neutral, and the live wire. So these are the 3 points. So we need to check the integrity of the cable physically, check for any damages. If you find any damages, you need to change this cable. Since our cable is in very good condition, we can continue with testing. So we connect this, we have a socket, we have a power socket. On the posterior aspect, it has a fuse. So this is the point where we connect the mains cable or the power cable. So the next step is connecting the machine. So when you connect the electrodes, you see that the cables are not twisted. Both the cables should be separate, they should not be closer. Okay, and here both the electrodes should be placed apart. There should be some space between them. Okay. Next we'll continue with testing the power plug. So first, when the switch is off, you are supposed to check it. So this has a child lock, so you need 2 testers preferably. So first you lift it and check the live wire. Okay, so you see that there is no glow in the bulb. When you connect it to the neutral, also there is no glow, and when you connect it to the earth, there is no glow. Okay, and next part is test it when it is switched on. When you switch on, we expect that the light in the live wire should glow. As you can see, the live wire is glowing. Very similarly, instead of 2 bulbs, I'm using two testers. Okay, now when I insert this tester to the neutral, you see both the bulbs are glowing, which confirms that both live and neutral are working. Next, I'm testing the earthing. So when I connect it to the earth also, there is glow, and the glow is same when I connect it to the neutral. So that means the earthing connection is also proper. Next, connecting the power cable. So once connected, I've switched it on, and then so next is testing the machine. But the first step is to switch on. As you switch on, this is the rocker switch which has an LED indicator. So you can see the glow of the indicator. That means the machine has switched on. Generally we wait for 2 to 3 minutes so that the machine gets sufficiently warm. The thermonic valve gets heated up and it is ready for the emission of the high frequency current. So next step is the power. So you increase the power to level 1, and finally the timer. So before you increase the timer, you place the hand to be tested. So you place your hand on both the electrodes. So you will see that the hand is placed properly and the contact is proper on both the electrodes. Okay, and then you increase the timer, and I can see some amount of warmth. Next, if you see the ammeter, it is showing you the reading. So when I move the ammeter, so you can see the points, different points where the intensity is increasing and decreasing. So I'm going to stop it where it shows the maximum reading. This is the point where it is showing you the maximum reading. I can feel maximum warmth when the machine is tuned. Now the ammeter is showing you the maximum reading at this level, that is the level 1. So I say that the machine is tuned. Okay, this is the first method of testing. Then I can bring the power to 0. So next method of testing is by using a fluorescent or neon lamp. Okay, so for insulation you can place a towel on the electrodes, but for demonstration I'm not using the towel. Okay, so I need to place the fluorescent lamp in the center of the electrodes, and I'll repeat the same. Switch on the machine, timer, the power, bring the power to 1, and I need to tune it. So as you see, when I have tuned it, the bulb started glowing, and same thing, I see that the ammeter is showing me the reading, and there is a point at which it is showing the maximum reading. This time I say that the machine has tuned. Now if I mistune it, you can see the glow is decreasing. So the point where you see the maximum glow, that is the point where you say the machine has tuned. And suppose if the patient feels that the warmth is very less, then you can increase the intensity. So whenever you increase the intensity, again you have to go check the tuning. So again you have to find the point where the intensity is maximum. So every time you increase or decrease the level of the power, again you have to tune it and see that there is maximum output of the machine. Next part is winding up. For winding up, we have a procedure. What we do is we bring the intensity to 0. Okay, then we don't bring the timer to 0 as it is spring based. Then you can switch it off and finally switch the power off. So this is the procedure of winding up, and you can replace all the items back to the cupboard. Thank you.